Public Exam Review for Advanced Math 3200. We will begin the Public Exam Review for Unit 5, Chapter 5 on trigonometric functions and equations. Here we will focus on graphing the sine and cosine functions. We will focus on sketching the graphs of y equals sine x and y equals cosine x, and we will determine the characteristics of the graphs of y equals sine x and cosine x. We will begin by graphing y equals the sine of x, and we will use degree measure. In the next slide, we will graph y equals the cosine of x, and we will use radian measure. In order to graph this function, I recommend using the unit circle. Notice I have a unit circle here that is labeled, and remember that any point on that unit circle given by x and y, that x represents the cosine of your angle and y represents the sine of the angle. So to begin, if I begin at 0 degrees, the sine of 0 degrees is equal to 0. So if 0 degrees, if x is equal to 0, the y value is also equal to 0. So the sine of 0 is 0. If I go to 90 degrees on a positive rotation around the circle, the sine of 90 degrees is equal to 1. So when x is equal to 90, y is equal to 1. So that gives us a second point on the graph of the sine of x. When x is 180 degrees, the sine of 180 is equal to 0. So we say that when x is 180, y will equal 0. And then if we go to 270 degrees, so when x is 270, the sine of 270 is a negative 1. And then if we make a full rotation around the circle, we're back at 360 degrees, which is coterminal with 0 degrees. And when x is 360, the sine of 360 is equal to 0. We have just drawn, or we are just drawing, one full cycle of the sine function right here. That represents one period of the graph. And the pattern continues. So it's a periodic function. So if you noticed here, we can repeat the cycles over and over again. If we do a negative rotation around the circle, a negative 90 degrees, you have the cosine to be a negative 1. The cosine of a negative 180 degrees would be here, and the cosine is equal to 0. The cosine of a negative 270 is the same as the sine of 90, which is equal to 1. And similarly, the cosine of a negative 360 degrees is the same as the sine of 0 or the sine of 360 degrees, which is at 0. So this is another full cycle of the sine function going in a negative or a clockwise direction around that unit circle. So the pattern keeps repeating itself. So at negative 720, the sine is at 0. At the sine of a negative 630 degrees is 1. The sine of a negative 540 is 0. The sine of a negative 450 degrees is negative 1. So this would represent another full cycle of the sine function. So we've done two rotations around the unit circle in a clockwise direction. If the pattern continues, the sine of 450 degrees is equal to 1. The sine of 540 degrees is 0. 630 degrees is at a negative 1. And 720 degrees, the sine is 0. So this would represent another full cycle. The main parts of this graph would be one full cycle around the unit circle in a counterclockwise direction. So this represents the main period of this sine function. It is very, very important to remember these key points found in this table of values, because it is these points that you will substitute into mapping rules when you are transforming the graph of sine x. Similarly, we can do the same thing to sketch the graph of cosine x. So we begin at 0 radians. We'll use radian measure this time. So at 0 radians, the cosine corresponds with the x-coordinate. So for 0 radians, the cosine is equal to 1. So that's also the y-intercept for the graph of cosine x. At 90 degrees, so we'll start off by doing a positive rotation around the unit circle. So at pi over 2 radians, notice that the cosine is equal to 0. So you have the point pi over 2 and 0 as an intercept. Then if you go to pi radians, the cosine is at a -1. At 3 pi over 2, the cosine is equal to 0. And one full rotation brings us back to 2 pi radians, which has the same cosine as the cosine of 0 radians, which is equal to 1. So this gives us one full cycle of the cosine function. Notice that it's in the shape of a V. But again, the pattern continues. If we go in a negative rotation around this unit circle, a negative pi over 2 has a cosine at 0. The cosine of a negative pi is a -1. The cosine of a -3 pi over 2 is the same as the cosine of pi over 2, which is 0. And the cosine of a -2 pi is equal to 1. So this gives us another cycle of the cosine function. The pattern continues to repeat itself. So the cosine of a -4 pi is 1. The cosine of a -7 pi over 2 is 0. The cosine of a -3 pi is a -1. The cosine of a -5 pi over 2 is 0. And this gives us another cycle. Similarly, on the right side, the cosine of a positive 5 pi over 2 is 0. The cosine of 3 pi over 2 is a -1. Cosine of a 7 pi over 2 is 0. And the cosine of 4 pi is a +1. The key points on this graph are found here. The y-intercept at 0, 1. This would be the main section of the graph that I would focus on. And again, to remember these key points in the table of values, because these are the points that you will substitute into your mapping rules when you're transforming the graph of y equals the cosine of x later in the unit. Let's look at the characteristics of the sine graph. Notice here that this is the graph of y equals the sine of x that we just graphed a few minutes ago. The period of the function is the length for which one full cycle occurs. So I'm looking at this section of the graph here. That's one pattern, we'll say. And the length for which that occurs gives us the period of the function. So the period of this graph is equal to 360 degrees. You also have to be able to give that in radian measure. The period is also equal to 2 pi radians. The amplitude of the function is the distance between the sinusoidal axis and a maximum or a minimum point on the graph. So in order to determine the amplitude of this graph, you have a couple of ways in which you can do it. The sinusoidal axis is a central line that passes through the graph. And the distance between that sinusoidal axis and the maximum or minimum point on the graph of your function gives you the amplitude for this graph. So in this case here, the distance between 0 and 1 tells us that we have an amplitude here equal to 1. So the amplitude in this case is equal to 1. The equation of the sinusoidal axis is a central line that passes through the middle of your graph. So in this case here, the central axis, or the sinusoidal axis that passes through this graph is through y equals 0. That's the equation of the sinusoidal axis, which is the x-axis in this case. You have two formulas that you can also use to determine the equation of the sinusoidal axis and amplitude of the function. You learned these in the chapter where the sinusoidal axis is equal to the maximum value plus the minimum value divided by 2. Here the maximum value of your function is at 1. The minimum value is at -1. So you have 1 plus a -1 divided by 2 equals 0 over 2, which is just equal to 0. So the sinusoidal axis passes through y equals 0. The amplitude can be determined by taking the maximum value of the function minus the minimum value of the function divided by 2. So the maximum value of the function is 1, and from that we will subtract the minimum value of the function at -1 divided by 2. 1 minus a -1 is 2 divided by 2, which equals 1. So that corresponds to the amplitude of the function. Notice that the x-intercepts here occur at 0, at 180, at 360, at 540, at 720. So if I make a list of the x-intercepts, they are at, some of them occur before 0. So you have 0, 180, 360, and so on. The x-intercepts can be identified as x belonging to any multiple of 180, 180n, where n belongs to the set of integers. When n is equal to 0, and 0 is an integer, you have 180 times 0, which is 0. That gives us the y-intercept here, or the first x-intercept. When n is a -1, you have another x-intercept at -180. Similarly, when n is a -2, you have another x-intercept at a -360. So x belonging to 180n, where n belongs to any integer, gives us all the x-intercepts for this function. The y-intercept is a very important point for the graph of sine x. The y-intercept occurs at 0, 0. And that's one point that will distinguish the graph of y equals the sine of x from the graph of y equals the cosine of x, which we will do in a few minutes. The domain of this function then will be all values of x such that x is any real number. X can be anything. It will always produce a graph, point on the graph of the function. The range, on the other hand, when you literally put your finger on the y-axis, note that the smallest value that y can be is a -1, and the maximum value that y can be is a +1. So we state the range as y such that a -1 is less than or equal to y, which is less than or equal to a +1, and y belongs to the set of real numbers. So these are the characteristics of the graph of y equals the sine of x using degree measure. Let's look at the characteristics of the graph of y equals the cosine of x, and notice here this time we will use radian measure. So the section of the graph that I want to highlight here, I want to go to the y-intercept there at 0, 1, and I'm looking for the V-shaped section of my graph. So that represents one full cycle of the cosine function, which occurs between 0 and 2 pi radians. So we say here that the period of this graph is equal to 2 pi radians, which is also equal to 360 degrees if you were using degree measure. The amplitude, again, is still the distance between the sinusoidal axis and a maximum or a minimum point on that graph. So we say here that the amplitude of this function is still equal to 1. Amplitude refers to distance, so it will always be positive. So here the amplitude is equal to 1, and the central line that passes through the entire graph is the x-axis, and that is also known as the sinusoidal axis in this case, and the equation of the sinusoidal axis is y equals 0, which is the equation of the x-axis. Again, you can use your formulas to determine the equation of the sinusoidal axis or the amplitude. The maximum value of the function is 1 plus the minimum value of the function at -1 divided by 2, which is equal to 0 over 2, which is just equal to 0. The amplitude can be determined by taking your maximum value of 1 and subtracting your minimum value of -1. Dividing that by 2 gives us 2 over 2, which is equal to 1, which is the amplitude for this function. Looking at the x-intercepts for this graph, note that there are some x-intercepts before the first positive one is at pi over 2. The next positive one is at 3 pi over 2. The next one is at 5 pi over 2, and the pattern continues. Notice to get from one x-intercept to another, we have x will equal pi over 2 plus 2 pi over 2, which is just multiples of pi to get from one to the other. So we say that the x-intercepts are given by pi over 2 plus pi n, where n belongs to the set of integers. And the y-intercept in this case, which again helps us to distinguish the graph of sine x from cosine x, the y-intercept for cosine is 0 and 1. So we say that the domain for the cosine graph is all values of x belonging to the set of real numbers. The range, on the other hand, are all values of y such that -1 is less than or equal to y, which is less than or equal to a positive 1, and y belongs to the set of reals. So these are the characteristics of the graphs of y equals the sine of x and y equals the cosine of x using degrees and radians, because you have to use both of them interchangeably. So let's look at some examples. Here we are asked to determine the equations of the sinusoidal axis and the amplitude of the function. So we can use our formula here. The equation of the sinusoidal axis is equal to the maximum value of the function plus the minimum value of the function divided by 2. In this case, the maximum value of the function is 5, plus the minimum value of the function is a -1, divided by 2, so we have 4 over 2, which is equal to 2. So the equation of your sinusoidal axis is y equals 2. Please note that this is the central line that passes through the graph of your function. So the sinusoidal axis is through y equals a positive 2. In order to determine the amplitude, we can again use our formula. The amplitude is equal to the maximum value of the function minus the minimum value divided by 2. So we have 5 minus a -1 divided by 2 equals 6 over 2, which is equal to 3. Again, go back to your graph, and the distance between the sinusoidal axis and a maximum or a minimum point on your graph, the distance between that is equal to 3, which represents the amplitude for this function. In example 2, we are asked, what is the period of the function graphed, and how does this affect the horizontal stretch of the graph of y equals the cosine of x? So what I would suggest here is that you pick out one full cycle of the graph. So I always begin with the first positive cycle. I'm looking for a V-shaped graph, and this represents one cycle. So the distance, or the length for which one cycle occurs, gives us the period of this graph. So the period here is equal to pi over 2 radians. Now, how does this affect the horizontal stretch of the graph of y equals the cosine of x? The normal period for the graph of cosine is equal to 2 pi radians. So in this case here, you have the period of your graph will equal the horizontal stretch multiplied by 2 pi. So the period of this graph is pi over 2 equals the horizontal stretch multiplied by 2 pi. In order to determine the horizontal stretch, you could divide both sides of the equation by 2 pi. So pi over 2 multiplied by the reciprocal of 2 pi, which is 1 over 2 pi, will give us the horizontal stretch. Note that the pi's will cancel, and you're left with 1 over 4 is equal to the horizontal stretch. So if you look at the equation of this graph, a horizontal stretch of 1/4 causes us to use the reciprocal in the equation. So in front of the x, you will see a 4, which is what is graphed here in this equation. So a period of pi over 2, the period of pi over 2 is 1/4 the normal period for the graph y equals the cosine of x. 1/4 of 2 pi is pi over 2. In the next example, it says, which horizontal translation of y equals the sine of theta would produce the same y-intercept as the graph of y equals the cosine of theta? In order to answer this question, I'm going to sketch the graph of both of these functions on the same grid. So I'm going to take the graph of y equals the sine of theta. I will use increments of 90 degrees, or I have to use radian measure here because our answers are in radians. So pi over 2, pi, 3 pi over 2, and 2 pi. The maximum value for sine or cosine is 1, and the minimum value is a -1. So the sine graph begins at the origin, 0, 0, and it ends at 2 pi and 0. So this is the graph of y equals the sine of x. Now, I need to take that graph and translate it either to the left or to the right to produce the same graph as that of cosine. The cosine function begins at 0, 1. So to just sketch the cosine graph, this is the graph of y equals the cosine of x. So what I'm going to do is I'm going to pick a point. I'm going to take the point pi over 2 and 1, and I'm going to move it pi over 2 units to the left. Pi over 2 units to the left would produce the same y-intercept as the graph of cosine. So that would be the horizontal translation that I will use in this example. So the correct answer for this multiple choice item is C. Let's go to a final example. Here we are asked to state the x-intercepts of the graph function, the function graphed. So if you look at the x-intercepts, you have one x-intercept at 0. This one is not labeled, but this one is at pi over 2. So what is halfway between pi 0 and pi over 2? Half of pi over 2 is equal to pi over 4. So that's the coordinate of this one, pi over 4. This one then would be at 3 pi over 4. Pi is the same as 4 pi over 4. This one would be at 5 pi over 4. 6 pi over 4 is the same as 3 pi over 2. So this one here would be 7 pi over 4. So if you're going to state all of the x-intercepts here, the x-intercepts occur for all multiples of pi over 4n, where n belongs to the set of integers. And that would represent all of the x-intercepts of the function graphed. So then, to sketch the graphs of y equals the sine of theta and y equals the cosine of theta in either degree measure, where theta is between 0 and 360 degrees, or in radian measure, where theta is equal to greater than or equal to 0, but less than or equal to 2 pi radians. You have to determine the coordinates of key points representing the theta intercepts, the maximums and the minimum values of the function. So the key points that are on this graph, and I want to highlight them, for the graph of sine x, it's at 0, 0, pi over 2 and 1, pi and 0, 3 pi over 2 and -1, and 2 pi and 0. That gives one full cycle of the sine function. For the graph of cosine, notice that it begins at 0, 1, pi over 2 and 0, pi and -1, 3 pi over 2 and 0, and 2 pi and 1. Those are the key points for each of those graphs, and those points you will have to plug into mapping rules in order to graph the transform functions. The maximum value for both functions is at 1. The minimum value for both functions is at -1. The amplitude for both functions is 1. The distance between the sinusoidal axis and a maximum or a minimum point on the graph is 1. The period for both sine and cosine is 2 pi. The y-intercept, okay, the y-intercept for the graph of sine, for y equals the sine of theta, the y-intercept is at 0, 0. For y equals the cosine of theta, the y-intercept is at 0, 1. So that's one characteristic that is different between the two functions. The theta intercepts for the cycle shown are at 0, pi, and 2 pi. So for the graph of sine, your x-intercepts are at multiples of pi. Pi n, where n belongs to the set of integers. Your x-intercepts, or your theta intercepts for the graph of cosine, sorry, I'm referring to that as x, but in this case here, the angle is given to be theta. So the theta intercepts here would be at pi over 2 plus multiples of pi to get from one to the other, where n belongs to the set of integers. The domain is the same. For sine and cosine, theta belongs to the set of real numbers, and the range is also the same for both functions. All values of y such that -1 is less than or equal to y, which is less than or equal to a +1, and y belongs to the set of real numbers. So these are the distinguishing characteristics that distinguishes one from the other. Thank you for your attention. If you have any questions, please ask them in the question forum, and we will be happy to answer them for you. Thank you.